Today we'll talk about how a spacecraft entered the sun's blistering hot corona for the first time in history. Let's head into it. A spacecraft launched by NASA has done what was once thought impossible. On April 28, the Parker Solar Probe successfully entered the corona of the sun, an extreme environment that's roughly 2 million degrees Fahrenheit. The historic moment was achieved thanks to a large collaboration of scientists and engineers, including members of the Center of Astrophysics, Harvard, and Smithsonian, who built and monitor a key instrument on board the probe, the Solar Probe Cup. The cup collects particles from the sun's atmosphere that help scientists verify that the spacecraft had indeed crossed into the corona. The goal of this entire mission is to learn how the sun works. We can accomplish this by flying into the solar atmosphere, says Michael Stevens, an astrophysicist at the CFA who helps monitor the cup. The only way to do that is for the spacecraft to cross the outer boundary, which scientists call the Alvin point. So a basic part of the mission is to be able to measure whether or not we cross this critical point. NASA's Parker Solar Probe has now done what no spacecraft has done before. It has officially touched the sun. Launched in 2018 to study the sun's biggest mysteries, the spacecraft has now graced the edge of the solar atmosphere and gathered new close-up observations of our star. This is allowing us to see the sun as never before, including the findings in 2 new papers, which were presented at AGU, that are helping scientists answer fundamental questions about the sun. The corona is the outermost layer of the sun's atmosphere, where strong magnetic fields bind plasma and prevent turbulent solar winds from escape. The Alvin point is when solar winds exceed a critical speed and can break free of the corona and the sun's magnetic fields. Prior to April 28, the spacecraft had been flying just beyond this point. If you look at close-up pictures of the sun, sometimes you'll see these bright loops or hairs that seem to break free from the sun but then reconnect with it. Stevens explains, that's the region we've flown into, an area where the plasma, atmosphere, and wind are magnetically stuck and interacting with the sun. According to data collected by the cup, the spacecraft entered the corona 3 times on April 28, at one point for up to 5 hours. A scientific paper describing the milestone has been accepted for publication in the Physical Review Letters. CFA astrophysicist Anthony Case, the instrument scientist for the Solar Probe Cup, says the instrument itself is an incredible feat of engineering. The amount of light hitting the Parker Solar Probe determines how hot the spacecraft will get, Case explains. While much of the probe is protected by a heat shield, our cup is one of only 2 instruments that stick out and have no protection. It's directly exposed to the sunlight and operating at a very high temperature while it's making these measurements. It's literally red hot, with parts of the instrument at more than 1800 degrees Fahrenheit and glowing red-orange. To avoid degradation, the device is constructed of materials that have high melting points like tungsten, niobium, molybdenum, and sapphire. But the success of the Parker Solar Probe represents much more than technological innovation. There are many mysteries about Earth's closest star that scientists are hoping the probe can help solve. For example, we don't actually know why the outer atmosphere of the sun is so much hotter than the sun itself, Stevens says. The sun is 10,000 degrees Fahrenheit, but the atmosphere is about 3.6 million degrees Fahrenheit. He adds, we know that the energy comes from the churning magnetic fields bubbling up through the surface of the sun, but we don't know how the sun's atmosphere absorbs this energy. In addition, outbursts from the sun, like solar flares and high-speed solar winds, can have a direct impact on Earth, disrupting power grids and radio communication. The Parker Solar Probe can help better understand all these phenomena as it continues to orbit the sun and take measurements and data for scientists to analyze here on Earth. Case says, the plasma around the sun can act as a laboratory that teaches us about the processes taking place in almost every astronomical object across the universe. This historic achievement of the Parker Solar Probe was announced at a press conference at the fall meeting of the American Geophysical Union, or the AGU. The press conference panel included former CFA scientist Justin Casper and Kelly Korek, who is currently on rotation at NASA headquarters. Both worked on the probe during their tenure at the CFA. The Solar Wind Electrons, Alphas, and Protons, or SWEEP, investigation is overseen by the Center of Astrophysics. SWEEP is a set of 4 instruments on the Parker Solar Probe, the Solar Probe Cup, and the 3 Solar Probe Analyzer sensors that measure ions and electrons. Other members of the SWEEP team include the University of California, Berkeley Space Sciences Laboratory, University of Michigan, the NASA Marshall Space Flight Center, the University of Alabama Huntsville, the Massachusetts Institute of Technology, Los Alamos National Laboratory, Draper Laboratory, Johns Hopkins University's Applied Physics Laboratory, and the NASA Goddard Space Flight Center. The Center of Astrophysics, Harvard and Smithsonian, is a collaboration between Harvard and the Smithsonian designed to ask and ultimately answer humanity's greatest unresolved questions about the nature of the universe. The Center for Astrophysics is headquartered in Cambridge, Massachusetts, with research facilities across the US around the world. What do you think about this insane mission? Tell us in the comments. This brings us to the end of our video. I hope you enjoyed it. Hit like if you did, and don't forget to subscribe to our channel so that you don't miss any of our videos in the future. Also, watch the 2 videos that are on your screen because I'm sure you'll love them. With that, I'll see you in the next video.